In this session, we will continue the discussion on Azure storage by diving deeper into Azure files. We'll talk about encryption, Bitlocker, Azure Key Vault, and Azure File Sync. We're going to use the whiteboard a bunch in this discussion, so get ready for what will be an exciting talk about another of the many core topics needed to build a successful cloud practice in Microsoft Azure. Enjoy the session.
In Azure, there's something called Azure Storage Service Encryption, or SSE, as an abbreviation that you'll notice in certain places. This is a low-level encryption of the data at rest on storage accounts or disks that is automatic and doesn't really require any configuration. So what that means is anytime you write data to a storage service, any type of storage, blob, files, disks, any of the ones we mentioned last time, your data is getting encrypted. So if in theory somebody were to steal a physical hard drive that has some Azure data stored on it and they were to plug it into another computer via USB, the data on that drive would be in an encrypted state, right? Which is what data encryption at rest is all about. The important thing to realize is that this data is encrypted with keys that are managed by Microsoft. And this is really not something that's configurable in the sense that you can't really control what keys SSE is using to encrypt the data. You cannot turn encryption off. And according to Microsoft, storage service encryption does not affect performance. So it's something that was rolled out actually not that long ago, maybe even this year or maybe last year, but it's not a trivial thing in the sense that it's important for lots of data compliance reasons to be able to say that data is encrypted at rest. And Azure Storage Encryption does that automatically. So any deployments with Nerdio for Azure or into Azure in general benefit from data at rest encryption. Sometimes we get asked if there is a way to encrypt data within the Azure environment using customer provided keys. And the way, for those of you who may not be familiar with how data encryption works, but there is public and a private key. The private key is or the public key is generally provided by you control it. Let's say the customer, the partner can control the key on behalf of the customer, and then encrypt the data as you place it, and then decrypt it as you retrieve it. Because Microsoft manages the keys for SSE, they in theory have keys to that data and they could decrypt it. So it's not really your own, and it's exposed, so to speak, to Microsoft. Usually, again, not a big deal, but important to realize that if customers ask for encryption using their own keys, what they can do is use another service that sounds very similar, but the distinction is it's called Azure Disk Encryption as opposed to Azure Storage Encryption. Disk encryption is designed specifically for IaaS VMs. So whenever you run a VM, if you recall, we talked about you must have an OS disk. Typically, that's a managed disk. We didn't even talk about unmanaged disks, which I think those are not as relevant anymore, so we're not going to talk about them. But managed disks can be encrypted, and those get encrypted with Bitlocker at the OS level using encryption keys that could be customer provided or could be custom keys, which are then stored within this thing called Azure Key Vault. And an Azure Key Vault is a service in Azure that's a secure repository for various types of keys. And one of the use cases for Azure Key Vault is to store the encryption keys, which can then be used to encrypt a disk attached to a VM, which is running on top of Azure storage, which is already encrypted, right? So what are you getting as a benefit of doing disk encryption? You're getting the use of your own keys that Microsoft isn't aware of because you're providing them and you're storing them in your own key vault, which in theory is not accessible to anybody but the administrator who sets up the key vault and the keys that are within it. The thing to keep in mind about disk encryption is, as I mentioned, it's done using Bitlocker, which is a feature of Windows. So it's something that runs within the operating system and encrypts the disks at the OS level. And it is something that can be triggered with PowerShell from within the Azure administration portal. You could do it all command line from outside of the VM. You don't have to be inside of the VM to do it, but it is a feature of Windows. It's the same BitLocker that is used, if you have a laptop and you want to encrypt the data on that laptop, so in case it gets lost, the data on it is unreadable, it would be the same type of functionality that's a standard feature in Windows. Okay, one thing to show you in the UI of Azure, if you go into a VM and you look at its disks, what you'll see is there's going to be a column for encryption, and you'll see that it says it's not enabled. And the reason it's not enabled is not because this data at rest is not encrypted, because it is encrypted with storage service encryption. What it's not enabled for is Azure disk encryption. So these disks are not encrypted with a custom key. It is encrypted only at the storage level. Let's look at Azure Files. So we talked about Azure Files. It's the ability to configure a SMB file share inside of Azure. So let's kind of draw that out. Let's say we have Azure Files, and let's say we have a share called public inside. Okay, so we have a share called public that is being shared out of Azure Files that's running inside of Azure. And that share can be connected to either through, let's call this FS01, or maybe even directly by a desktop, right? So these Windows machines can map a drive, and let's say they call it P and P. So they can basically map a drive directly to this. It's going to be, something like // some sort of a URL / some sort of an ID, / public is going to be the way this is going to be presented. So you can simply run a command, and as long as you have network level access into this share, you're able to map it as a drive. The important thing to keep in mind as far as limitations go for Azure Files is that Azure Files currently are limited to being in standard storage only. And as you recall, standard storage is based on spinning media, so HDDs, not SSDs. It is something that's currently in limited preview to allow Azure Files to be in premium storage, which is going to be much faster, higher throughput, more IOPS, etc. But being in standard storage means that if you're, for instance, mapping to Azure Files from a VM that's running inside of Azure, let's say it's in the same region, so physically close to each other, you have a VM called FS01, and you have a Azure file share called public. If you map from one to the other, the networking is going to be relatively fast because they're in the same region, but the disk performance may not be that fast because it's standard storage. And if you imagine having to map to an Azure file share outside of the same Azure region, so either in another Azure region or from an on-prem system, let's say from a laptop that you're traveling with, then you have two constraints. You both have standard storage, which gives you, fairly slow disk performance, and you now have also some network latency, which wouldn't be different than mapping a network share or a drive to a network share in a file server that's somewhere on the other, across a WAN connection. Okay, so same types of limitations. The other limitation of Azure Files is the fact that at the current time, it is not integrated with Active Directory. Okay, so what does it mean it's not integrated with Active Directory? The typical way you use Azure, you use file shares is you present a share that's open to everyone with full control, and then you're using NTFS with access lists on a per group or maybe per user basis to segment who has access to what. As you can imagine, that type of access list NTFS control requires being aware of the account IDs or the group IDs within an Active Directory. And Azure Files currently does not support Active Directory integration, which means that the only way to limit access is on a per share basis, not per folder or file within a share, and also to do so based on the source connector and not on an individual user that's logging in to that particular file share. Okay, so those are the limitations. It is currently, I think it's maybe still in limited preview, maybe in public preview, or maybe even be in GA, but I think they now have a feature that integrates Azure Files with something called Azure Active Directory Directory Services, which is kind of a way of being able to use your existing Active Directory and manage Azure Files and other similar services to be able to be familiar or aware of the security IDs of the various accounts and group identifiers, so you can limit access based on NTFS permissions. Okay, so that's kind of Azure Files at a high level. Not super useful in its current state for typical deployment. Why? Because, you know, imagine we're using something like public or even users where we redirect the desktop and documents folders to, or a UPD, a user profile disk. Imagine if you're doing that into standard storage, the performance wouldn't be good enough to where the user performance on the desktop wouldn't suffer as the result. So imagine all of the desktop items are redirected to an Azure file share. Even if it's in the same Azure region, you have fairly slow disk performance that you can't really increase. So if users start working on large files, opening large files, saving large files, they may run into those performance limitations. With Azure Files being compatible with premium storage, that's going to go away. It's going to be a little more expensive, but it's going to eliminate that limitation. But the other significant limitation is whenever we, again, using as an example, desktop and documents folders, when those get redirected, they're always limited to the user who needs to have access. You know, public shares generally open to the domain users, but department shares and user shares are usually limited on a per user basis. And that is not something that's currently possible in Azure Files without using this ADDS, which is kind of a different service and add-on service. So how do you make use of Azure Files? And the way you can make use of Azure Files is using something called Azure File Sync, okay? So it sounds kind of similar to Azure Files, but it's actually a feature that runs on top of Azure Files and does the following. So imagine you have an Azure File share, call it public, in front of it. So imagine you have an Azure File Sync service, which is an Azure service. So Azure File Sync service sitting in front of Azure Files. And then what you do is you can create sync servers. Let's call it FSO1. And let's say there's another one that's maybe on premise, call it, I don't know, let's call it, file 01. Okay, so let's say this is on-prem and this is in Azure. So what these servers are, they're called sync servers, and they can now communicate with Azure File Sync, and they can synchronize the contents of this share with an equivalent share inside of these VMs. Okay, now the great thing about this is that the share inside of these VMs is presented to the user. So let's say we now have a WS01 here, and this WS01 is a client of this file server. So this file server can present public as a regular folder and a regular share inside of its own disk and operating system with all of the regular NTFS capabilities, and it will be consistent as it syncs to other servers. Okay, so it's a way of kind of creating a cache of the Azure Files data locally on the file server that's close to the clients that are accessing that data. So it makes it faster and also allows for NTFS permission. So it's because it's Active Directory aware and it's just regular file services. So for instance, if you have, you know, 2 or even let's say 3, let's say you have FSO2 in a completely different Azure region, also connected to this file share. Anytime a change is made here, this change is going to get replicated here and here through this common Azure File Sync service, which is accessing data that's stored in Azure File Share. Now, what you could also do is you can map and make a change directly on the Azure Files, right? So let's say you make a change up here, that change within 24 hours, because it's got to detect that the change has been made, but within 24 hours, there's a change detection job that will run, and that change will appear on every sync server that is currently syncing to that file share through Azure File Sync. Now, when would you want to use something like this? Why not just use a single file server, set up the data on a disk, share it out with file sharing like it is traditionally, since it is something that has to be done anyway, right? We still have a file server involved. So why not just do that traditionally? Why do we need all this complexity of having Azure Files, Azure File Sync, and then all of these different things going back to it? Well, the reason is that Azure Files, especially when stored on standard storage, is very cheap. So the cost of storage starts and goes lower than 8 cents per gigabyte per month, right? Which is really cheap. Now, if you imagine you have a customer that has a huge amount of data, let's call it, 10 terabytes or something, they can put it into Azure File Sync, and 10 terabytes will cost you, what is that? That's $8 per terabyte. So that's $80. Right, so 10, 100, so more than that, it's $800, but still that is very cheap if you think about how much storage that is. So you can place all of that storage into Azure Files and then set up sync servers or a single sync server that can be the cache into that data. So when you need to access a file, the file is available locally and is quick, it's close to you via network. And it's also stored on faster storage within this FSO1, for example. You can have access to this data that's faster, but store it in Azure Files at a cheaper rate. The only way this works is when you use something called tiering. Okay, so tiering is a feature of Azure File Sync that basically is configurable, how aggressive you want it to be. But the concept behind tiering is you tell a file server and a sync server like FSO1 what files to download and what files to only maintain pointers for. So if I'm on WSO1 and I have 10 terabytes of storage up in Azure Files in a share called public, that share is synced to FSO1 via Azure File Sync. FSO1 then shares that folder called public to me as a share called public. So now I'm mapping a drive to it. I open it up and I see I have 10 terabytes worth of data with 10 million files, however many files are there. When I double click on a file, that file most likely isn't going to be on this FSO1 yet. It is going to be only in Azure Files. So what's going to happen is FSO1 is going to request that file and is going to get downloaded, stored locally, and then passed down to WS01. And then as WS02 or 03 or anyone else accesses that file, it's going to now be local, and changes that are made to that file are going to be uploaded to Azure Files. And if that file is local on any of these other servers, it's going to be downloaded there as well. But if not, it's just going to be kept in Azure Files. And then eventually, once that file becomes old and stale and it's not being touched often, it's going to be tiered again, which means it's going to be replaced with a pointer and the data is going to stay in Azure Files. So what you can do effectively is take a huge amount of data, and if most of it is inactive, you can allow it to be stored in very cheap storage in the cloud and make it accessible quickly through sync servers, which then present that data as file shares to the client VMs, right? So we talked about leveraging cheap storage. That's one use case of Azure Files. The other use case is data migration. Let's say you have this server. Let's say you have this server right here, which is your on-prem server, and you have a lot of data on it, and you want to have a seamless way of migrating it into, let's say, this server, right? And you want to either use Azure Files long-term or maybe not even use Azure File long-term. So what you'll do is you set up an Azure File share. You're going to create Azure File Sync service inside of that account. You're then going to make this on-prem server a sync server, which is going to suck up all the data up here, right? And then you're going to create this server also as a sync server, and you're going to set up tiering so that even though all the data will be stubbed or pointers will be available on FSO1, none of it will actually get downloaded, or most of it won't get downloaded to FSO1. So you can kind of set up the structure, maybe even with a separate folder. Let's say FSO1 currently has, a lot of data you want to migrate. You can set up a folder called a transfer. Set up this whole, structure. Set up an Azure File share. Set up Azure File Sync service. Set up a transfer folder here. And then simply copy files from wherever they currently are on file 01 into that transfer folder, and those will automatically start appearing in FSO1.